Hey guys, I want to continue along with what we were just talking about. Okay, so we have this idea that big F is the antiderivative of a little f. So we have to kind of reverse the differentiation process. And we found out that when we did that, okay, I can see, to get 60 as the derivative, I had to have 60x. So, but then I have to add a plus c because any constant could have worked such that f prime of x does give me 60 as the derivative, right? I could have had any constant over here, 60x. If I have 60x plus c, any c would work. So why, in my example, this is just big, I'm going to call it big F instead of b now. This is big F of x is 60x for this part. So why did I know just to use 60x? Well, it's because I gave a condition. So oftentimes with the antiderivative, we might be given a condition. The condition was that the patrolman started, he was starting from his home base, starting from a stop. So I know there was no velocity to start with. So I know my initial velocity was 0. So I just put, since I knew my initial velocity, in our case, since we're working with velocity, our c we can think of as v sub 0, our initial velocity. I knew it was 0. So I could just plug in a 0 for c, and then I have my velocity function here. So notice that the accumulated net area is exactly equal to reading off the value from what we've been calling our velocity function, and we're now calling big F of x. Okay, well, what about this second one? As we went from 1 to 3 hours, he was just cruising along, so there's no acceleration as he goes hour 1 to hour 3 here. There's no acceleration. Well, what will we have to have in order to get 0 as the derivative? So here, we're thinking of this as little f. Little f of x is 0. What does big F have to be to give us 0 as the derivative? Well, any constant, right? So if big F of x is c, big C, then for any constant, then f prime of x is little f, which in this case is the constant function 0. Okay, so it could have been any constant. So how did I know to leave the constant 60? Because under our scenario, we had accumulated net area up to 60, and I said, well, he's just going along at the same pace. So the scenario I gave us told us that that particular constant that I'm going to use is big F of x is 60. So this is just the constant function, big F of x equal to 60. Okay. What about our next scenario? Okay, so we're calling this little f. Little f, which is our acceleration, was a negative 120 as we went from 3 to 3.5 hours. Okay, it's a negative 120. Okay, well, what had to be big F of x? Big F, in order to get negative 120 as the derivative, remember little f has to be the derivative, big F of x had to be 120x, right? And then, of course, I got to put a plus c, because I'm not sure, I have to have conditions to lock down this c, but in general, it could have been anything. Okay, so big F of x would be 120x. Oh, I'm sorry, it's a negative 120, of course, so a negative 120x plus c. Okay, so big F of x is negative 120x plus c. Now, again, with my conditions, I knew we'd just been cruising along, so he was still going 60. So my conditions tell me that big F of x is negative 120x plus 60. So that is what I've graphed here. So this is giving us, or getting our net accumulated area between the sum of our net accumulated area is being given to us by this antiderivative given the specific conditions where I can lock down that c. Okay, so that's what we were doing. That's what we've been doing, actually, ever since I introduced the topic. I'll talk with you soon.